In the last lecture, we have seen about the statement of the combined statement of the logic, and now here what is meant by statement pattern. That is the new topic of this mathematical logic, logical equivalence. Then there are statements of the same type, that is tautology, contradiction and contingency. So first of all, what is meant by statement pattern, that we define here, because we have seen the logical statement. So on the basis of logical statement, this statement pattern is defined here. So here proper combination of the statement letters and connectives called as the statement pattern. So we have used here, that is letters P, Q, R, etc., and we have seen the logical connectives and or implication, double implication and negation. So here in the statement pattern, at the same time we are using the proper combination of the statement letters and the connectives, and this is called the statement pattern. Therefore we have defined it as a statement pattern. Now next part of the statement pattern, so there are different questions can be asked. So we want to show that the two statements are equivalent. So this is called the equivalence here. So we say that two statement patterns A and B are equivalent. That is A equivalent B means first statement pattern truth values and second statement pattern truth values having the same truth values in their last columns, and then we can say that two statement patterns are equivalent. So this is equivalence between the two statement patterns. Now these statement patterns are classified into three types here. So first type is a tautology. So this is your tautology. How can you define the tautology? So when we consider the statement pattern, so we want to say that it is a statement pattern is a tautology. So we define here statement pattern has truth value true for all possible combinations, that is truth value is t, then that statement pattern is a tautology. On the same basis, we can define the contradiction. What is meant by contradiction? So again we define statement pattern has truth value false for all possible combinations, that is F. So the statement pattern is called the contradiction. And further, third type of the statement, it is contingency. So how can you define the contingency? It is a very easy. Statement pattern neither tautology nor contradiction called as a contingency. So here in the contingency, in the last column of this statement pattern, truth values t as well as f exist, and such type of statement pattern is called the contingency. So in this way, given statement pattern, we have seen the equivalence relation between them, and further it is divided into three statements, that is tautology, contradiction and the contingency. Now we come to the proper example of this type. So only we write here, construct the truth table for the given statement pattern. P implies Q implies P. Now here only the statement pattern is given, and now we want to decide here out of these three types, tautology, contradiction and the contingency, which one is the given pattern. So we take the truth table solution here. The given statement pattern, that is P implies Q implies P, and the truth table for it. So always we take the preliminary statement, or we can say that the parent statements P and Q in the first two columns. So sequence of the truth values are always to be maintained here. TT, TF, FT, FF means P is true, Q is true, P is true, Q is false, P is false, Q is true, P is false and Q is false. So this sequence to be maintained in each and every table. Now, as per our requirement of the statement, bracket statement truth values to be obtained first. So here Q implies P. You have to remember here implication is from left to right, means Q is your first statement and P is the second statement here. Therefore always say here Q is the first statement and P is the second statement. So as per the order, we have to consider Q is the first statement and P is the second statement. And according to the rule of implication, we know that for TF value, first statement having the truth value T and the second statement having the truth value F, their implication is false only. That we have seen in the previous example. So here your Q is the first statement, P is the second statement. So we find Q is true and P is false. So we take it TT, FT and TF. So here Q is true and P is false, and therefore by the rule of implication this Q implies P is false. So this is to be noted here for the rule of implication. And remaining values as per the rule, they are true, so you don't discuss those values there. So remaining values, they are T, T and T. So that is Q implies P. First combination is true, second combination is true, and as per the rule this is false and last value is false. So this is the Q implies P. Now this bracket term Q implies P, that is again connected with the statement P by the connective implication. So here remember here P is the first statement and Q implies P is the second statement. So we come to the columns here. P is the first statement, Q implies P is the second statement. So as per the rule of implication, because these two statements are connected by implication, and therefore again we adopt the rule, your P must be true and your Q implies P must be false, then it implies false. So we check it. First statement should be true and other statement be false, whether this exists or not, that we compare here. So your first statement is true, second statement is true, so no question of falsity is there. First statement is true, second statement is true, again no question of falsity is there. First statement is false, second statement is false, again no question of the falsity is there. First statement is false and second statement is true, so again no falsity. But as the last pair it is in the inverted, that is first is true and second is false, then we can definitely write here false statement. But here as per the rule no TF values existing there, and therefore blindly you can write in the last column first combination is true, second combination is true, third is true and fourth is true. So in this way this statement pattern having all the truth values T, 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 T. And now the question, we come to the question here. Question is only construct the truth table for this statement pattern. But we go further here and we find the type of statement here. So this is our required solution up to this. But we come to the tautology, contradiction and the contingency. So, according to the definition of the tautology, all the values of these statements in the last column, they are true, and therefore, by the definition, given statement pattern is a tautology. So, in this way, we can decide this statement pattern here. So, sometimes the question is like this, find the truth table and interpret your result from the last column. Interpret your result from the last column. So, what we can say from the last column? All truth values are t, and therefore we can interpret instead of this given statement, we interpret that statement pattern is a tautology. So, this will be your expected answer for the interpretation.